Okay, guys, so we are going to use the quadratic formula as a method for solving quadratic equations. And the really cool thing about the quadratic formula is it works every single time. So we saw when we were factoring that sometimes some things are factorable and sometimes some things are not factorable. So factoring is not a foolproof method for solving a quadratic formula or equation, but the quadratic formula is. And so this right here is the quadratic formula. X equals negative b, or you'll hear me say the opposite of b, plus or minus. So that means we're going to have two answers. One will be the positive of all of this, and the other will be the negative of all of this. So the opposite of b plus or minus the square root of b squared minus 4 times a times c, and all of this is divided by 2 times a. All right. Notice that this expression underneath the radical, underneath the square root, is in a different color. B squared minus 4 times a times c. That's in orange. That is referred to as the discriminant. And the discriminant helps us to determine the number of solutions that a quadratic equation has. So our discriminant, b squared minus 4 times a times c, is called the discriminant, and I'm just going to refer to that as d. When the value of d is greater than 0, we have two real solutions. When the value of d is equal to 0, we're going to have one real solution, and when the value of d is less than 0, there are no real solutions. So in other words, right here, interpreting the discriminant. This is our discriminant. When we plug the numbers in there and we do the math, and this value is greater than 0, we have two real solutions, two x-intercepts. So our graph would resemble this. When we plug our numbers into the discriminant here and we do the math and it comes out to be exactly 0, that is when we have one real solution, or one x-intercept, and visually our graph would look something like this. And then last but not least, the third possibility is we plug the numbers into the formula for the discriminant right here, and we do the math, and this value works out to be less than 0. So that means it's going to be a negative number, and that means we have no real solutions, or there are no x-intercepts. And that makes sense, because if this number works out to be less than 0, works out to be a negative number, then what we're saying here is we're trying to take the square root of a negative number. And we know that can't happen. We talked about that several chapters ago, and we have revisited that in this chapter as well. So let's take a look at a couple of examples. So this first one here, I want to solve these two equations using the quadratic formula. So basically, I need to look at these two equations, and I need to determine the value of A, the value of B, and the value of C, and then plug them into my quadratic formula appropriately. So the way that I determine the value of A, the value of B, and the value of C is to make sure that everything is on one side of the equal sign, that I am in standard form, highest degree to lowest, and my leading coefficient is positive, which we have been practicing throughout this chapter already. So if I look at what I have here, everything in problem number 1 is on one side of the equal sign. We are in standard form, highest degree to lowest, and our leading coefficient here is 1. So how do we determine the value of A, B, and C? Well, because when we're in standard form of a quadratic, that is ax squared plus bx plus c. Oops, this purple is not really working. So if I write that directly above here, we can see how this lines up. So our value of A is 1. Our value of B is a negative 6. And our value of C is positive 5. And we need to take those three numbers and plug them back into our quadratic formula. So our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that is divided by 2 times a. So I'm going to go ahead and plug these values in here. So I need the opposite of b, or the negative of b. Well, our value of b is a -6. If I plug a -6 in here, double negative is going to make a positive. So I have 6 plus or minus the square root of -6 squared minus 4 times a, which is 1, times c, which is 5. And then all of this is going to be divided by 2 times a, which is 1. Okay, so all I did was take those three numbers and plug them back into our formula for the quadratic equation. And when I substituted here, notice that I put these in parentheses. Whenever we substitute, we put those numbers in parentheses. So now I need to essentially clean this up. I need to do the math. So a -6 squared, a -6 times a -6 is a positive 36. So I'm going to have 6 plus or minus the square root of 36. And then I have -4 times 1, which is -4. And then -4 times 5, which is -20. So 36 minus 20. And all of that is going to be divided by whatever 2 times 1 is, and 2 times 1 is 2. Okay? 36 minus 20 is 16. So I'm coming over here so I have more space. So I'm going to have 6 plus or minus the square root of 16. All of that is divided by 2. And the square root of 16 is 4. So 6 plus or minus 4 divided by 2. So my two answers are going to be, one of them will be 6 plus 4 divided by 2. And the other is going to be 6 minus 4 divided by 2. So I need to figure out what these two things are. 6 plus 4 divided by 2 and 6 minus 4 divided by 2. So that's going to give me 10 divided by 2. So one of our answers is 5. And 6 minus 4 is 2. 2 divided by 2 is 1. So there are the two solutions. Next up is this guy. So again, we need everything to be on one side of the equal sign. We need it to be in standard form, highest degree to lowest, and we need our leading coefficient to be positive. So right now, this -1 needs to move this way. So to undo a -1, we're going to do a +1. So we'll add 1 to both sides. So that will make this 4x squared minus 4x plus 1 equals 0. So now we are in standard form, highest degree to lowest. Leading coefficient is positive, and everything is on one side of the equal sign. Next up is to identify our values of A, B, and C. So this is our A right here. A is 4. This is our B right here. B is -4. And this is our C right here. C is 1. Because in standard form, we have a x squared plus bx plus c. So our ax squared plus bx plus c. I'm going to use this orange because these colors are running wonky here. So again, just to reiterate, our a is 4, our b is -4, and our C is +1. And I'm going to take those three numbers and I'm going to drop them into the quadratic formula. So the opposite of B plus or minus the square root of B squared minus 4 times A times C, and all of it is divided by 2A. So I need the opposite of B. So RB is actually a negative 4. I need the opposite of that. So 4 plus or minus the square root of B squared. So that's going to be negative 4 squared minus 4 times A, which is 4, times C, which is 1, and all of that is divided by 2 times A, which is 4. And then I need to simplify this. So a negative 4 squared, negative 4 times negative 4, that's going to give me 16. So I'm going to have 4 plus or minus the square root of 16. So this gives me 16. And then I have a negative 4 times 4, which is a negative 16. And a negative 16 times 1 is a negative 16. So minus 16. And all of that is going to be divided by 2 times 4, which is 8. So 16 minus 16, that gives me 0. So I have 4 plus or minus the square root of 0 divided by 8. And the square root of 0 is just simply 0. So I end up with 4 plus or minus 0 divided by 8. And this is just going to give me 4 in the numerator. So I have an answer of 4 over 8, or 1/2. So we have one solution here, and that one solution is x equals 1/2. All right, next up, and the final topic here is using this discriminant, b squared minus 4 times a times c. This is the expression that is under the radical, using that discriminant to determine the number of real solutions that we have. So it's very similar, in all honesty, to using the quadratic formula. We have to make sure we're in standard form, everything's on one side of the equal sign, and our leading coefficient is 1. And then we need to identify the values of A, B, and C so that we can plug them into the discriminant and do the math. And then we're looking to see if that number is greater than 0, equal to 0, or less than 1. So if I look at number 3, this is absolutely in standard form, highest degree to lowest. Leading coefficient is 1, and everything's on one side of the equal sign. So this is our ax squared plus bx plus c. So our a is 2, our b is negative 3, and our c is negative 1. So a equals 2, b equals negative 3, and c equals negative 1. And I just need to take those 3 numbers and plug them into the formula for the discriminant, which is b squared minus 4 times a times c. So I need b squared, so a negative 3 squared minus 4, times a, which is 2, times c, which is negative 1. There's no square root here. The discriminant is just what is underneath the radical. So there's no square root. We're just plugging those numbers into this, and we're going to do the math. So that's going to give me 9. Negative 3 squared is 9. 4 times 2 is negative 8. Negative 8 times a negative 1 gives me a positive 8. So this is really 9 plus 8. And 9 plus 8 is 17. So the value of our discriminant is 17. So now the question becomes, is 17, is our value, is D, the discriminant, which we found to be 17. Is D greater than 0, equal to 0, or less than 0? Well, 17 is greater than 0, so that means we have 2 real solutions. And then we need to do the same thing over here for example number 4. We need to get everything on one side of the equal sign. We need to make sure we're in standard form, highest degree to lowest, and our leading coefficient is 1. So to do this successfully, I'm going to go ahead and subtract x from both sides. So that will give me x squared minus x plus 4 equals 0. And then I need to figure out what are my values of a, b, and c. So again, ax squared. So ax squared plus bx plus c. So our a is positive 1, our b is negative 1, and our c is 4. So a equals 1, b equals negative 1, and c equals positive 4. Plug those numbers into that formula right there for the discriminant, b squared minus 4 times a times c. So I'm going to have b squared, so negative 1 squared, minus 4 times a, which is 1, times c, which is 4. And then I need to do the math. At this point, you can just plug that into your calculator exactly the way that you see it, and your calculator will do the order of operations for you. But this is going to give me 1, and then a negative 4. Negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. 1 minus 16 means that our discriminant is equal to a negative 15. So our discriminant has a value of negative 15. So our three choices are the discriminant is greater than 0, the discriminant equals 0, the discriminant is less than 0. We just said our discriminant is a negative 15. So that means our discriminant is clearly less than 0. So we have no real solutions. So since our discriminant is less than 0, there are no real solutions.